few more examples to work through on this page, on page 82. Reminding you what we did in our last video. We isolated the radical. We got rid of the radical by squaring both sides. And after we found our solutions, we went back and checked them. So the radical is not alone. I need to subtract 2 from both sides to get the radical alone. A minus 3 equals 5. Square both sides. And I get A minus 3 equals 25. Add 3. And I get A is equal to 28. I'm not finished because I need to go check my solution. So I'm going to plug 28 in for A and ask ourselves, when we clean all this up, do we really get 7? So 28 minus 3 is 25. Note the 2 is not underneath the radical sign. And yes, looks like this one works great. So 28 is our solution, and our check proves it. So let's look at this next one. We're going to square both sides. The radical is isolated. So I am going to end up with x squared equals x plus 20. Now, this is the first one we've done where we have a quadratic equation here. So we've got x to the second power. We know we're going to end up with 2 solutions. We know we're probably going to end up factoring. All kinds of different stuff applies when you're dealing with quadratic equations. So that's okay. Let's see what we got. Let's bring everything over to this side and set it equal to 0, because that's how we solve quadratic equations. This is pretty easy, I think, to see the factoring. 5 and 4 multiply to 20, and negative 5 and positive 4 will work. If you want to go back and review the AC method, fine. If you can do it in your head, even better. So when we set both of these equal to 0, we end up with x equals 5 and x equals negative 4. And I'm going to go check them both. So I'm just going to do the check probably right underneath if I've got room. So I think x is 5, so I'm going to plug 5 in here, and I'm going to plug 5 in there and ask myself, does that work? Is 5 equal to the square root of 25? Yes, it is. So yes, this one works. Negative 4, let's see what happens. We'll plug in negative 4 in 2 places. So negative 4, square root of 16. The square root of 16, it's the positive root. So negative 4 does not equal negative 4. We have to throw this guy out and say he is extraneous. So one solution works, one is extraneous. I think I'm just going to go ahead and go through these next 2 without doing another video. I think we can just do a couple extra minutes on this video. So nothing different here to the process. When we square both sides, it'll look a little bit different. But let's go for it. So this is what we have when we square both sides. Now, notice we've got this binomial that is going to need to be multiplied times himself. So we are going to need to do a double distribution here. And when you do that, and you can go do that on your own, you're going to end up with x squared minus 8x plus 16. And you might just see you can do this in your head. And now we need to set it equal to 0 again, because I've got a quadratic equation. So this is x squared minus 8x minus 2x plus 5 plus 16 equaling 0. Cleaning it up, x squared minus 10x plus 21 is equal to 0. And now we're going to go back and factor this again. So we're looking for partners, factor partners, that multiply to 21 and have a negative 10 in the middle. And I'm seeing negative 7 and negative 3. And again, you're going to double distribute to see if you've got the right answer. And this does actually work. So we're going to set each one of these equal to 0. and we get x is equal to 7 and x is equal to 3. That's the first part. Now we've got to go check them. So let me go get another color over here. So the check for 7, we plug 7, and we're going back to the original guy, this guy right here, for the check. So I'm going to say 7 minus 4, is that really equal to the square root of 2 times 7 minus 5 on the outside? So 7 minus 4 is 3. Is that equal to the square root of 14? Wait, the 5 is in there. Oops, sorry. So 14 minus 5, so that's the square root of 9, which is positive 3. So yes, this is a good solution. When we try 3 back in the same exact equation, we get 3 minus 4 is equal to the square root of 2 times 3 minus 5 minus 1 equals the square root. That would be 6 minus 5 minus 1 is equal to the square root of 1, and minus 1 is not equal to positive 1. So this one we throw out and we say it's extraneous. All right, let's do this last one and then we'll finish up this unit. All right, the radical is not alone. So the first thing we need to do is subtract x from both sides. Please be aware of that. That's the very first thing that you need to look at. So now we have something that looks like this, and now we're going to square both sides. So we have 5 minus x squared, which is 5 minus x times 5 minus x, equaling 18 minus 2x. So when we double distribute, we are going to end up with 25 minus 5x minus 5x plus x squared equals 18 minus 2x. We need to set all of this equal to 0. I'm going to write this in standard form. I need to get this x squared first. So I'm going to clean up this side. X squared minus 10x plus 25. And then I'll subtract the 18 and add the 2x to get it equal to 0. I'm going to keep simplifying, keep combining my like terms here, and I get x squared minus 8x plus 7 equals 0. And now I'm looking for factors that multiply to positive 7 and add to negative 8. So that becomes x minus 1 and x minus 7. So when we solve, we get x equals 1 and x equals 7. And of course, we have to check. So we're going to go back to the original equation, which is this guy way back up here at the top, and that's what we're plugging in. So we're going to start with 1 and say, okay, 5 equals the square root of 18 minus 2 times 1 plus 1 on the outside of the radical. So 5 equals square root of 18 minus 2, which is 16, plus 1. 5 equals square root of 16 is 4. And this answer looks like it's perfectly fine. When we try the 7, we get 5 equals the square root of 18 minus 2 times 7, which is 14, plus 7 on the back end. So we get 5 is equal to 4 plus 7. The square root of 4 is 2 plus 7. And 5 is not equal to 9. So this guy is extraneous. And that is the end of this video. See you in class.